Hello and welcome to Advanced Data Science Capstone project. It is part of Advanced Data Science with IBM and let us start with this Capstone project. Initially we start with data exploration module. In case of my project's name is Coursera Capstone Shoppers Intention Prediction. So I have downloaded this entire data set is from Kaggle website, and this is first phase of documentation, initial data exploration. So data has been given by C. Okar Sakar, Department of Computer Engineering, and Yomi Castro, Information Technology Consultancy Trade, Istanbul, Turkey. And I am Kapil Nagwanshi. So this data set, this is source and data set information. This data set consists of feature vector belonging to 12 330 sessions, and data set was formed so that each session would belong to different users in a 1 year period to avoid any tendency to a specific campaign. The page URL is this, and there are 10 numerical and 8 categorical attributes. These are the attributes. Initially we start with imports of different libraries, and we import the data frame, read the CSV file into data frame df, and then exploration of data. This is head information, 5 rows of the data set, and this is description of data set, which describes the columns, or different numerical columns, so that one can easily identify what we need to do for prediction. And this gives the data frame data types information. It includes a float, integer, object, and boolean type of data. This gives the missing value per column, administrative duration, all the things, and we will check to see if there are any not a number values. So these are the not a number values in different rows. So we need to drop all these things and find the unique month, and we copy the data frame into data set so that we can explore beautifully the data set. So this gives the percentage of website based on type. The types of websites include administrative, informational, product related, admin and info, admin and product. These are the categories. So out of these categories, first is product related. It shows 93.89, and second is administrative, 52.18%. So this is one exploration, and this is another representation. Total share, how many percentage of revenue based on website type. Here it is done on the basis of administrative, informational, product related, admin and info, whatever we have seen in this website type graph. Now come to uh, the exploration of different columns: operating system, browser, region, traffic type, visitor type, weekend, revenue, and month. So this gives the count, unique value, top, and frequency. And this is another statistical analytics detail of the data exploration. This gives the univariate analysis: number of data with respect to operating system, number of data with respect to operating system, with respect to browser, with respect to region, traffic type, visitor type, weekend, revenue, and month. From these plots, all these plots, we can conclude that the target variable revenue is imbalanced. Data was not collected in the month of January and April. The data collected is not uniformly distributed among the month and region. Operating system, browser, traffic appears to have some categories missing. These are the plots with respect to true, false, January, June. These are the distribution plotted with the help of SNS. Box plot for outlier. Here we can see the box plot, what is the lowest value, what different outliers in each category. So this bounce rates give no outlier in false category. In true, some outliers are there. For revenue it is given, and not for revenue versus exit rates, revenue versus informational duration, and so these are the exploration. Now this is the distribution plot again for bounce rate, administrative duration, exit rates, and this gives the joint plot of different categories of values. This is the pair plot. We have some columns, same value is plotted with the same value, so it gives correlation in diagonal values, like administrative is related with correlated with administrative and other thing. Similarly, this is also pair plot for a transformed data set, and this is a untransformed data set. For an untransformed data set, this gives the heat map of numeric column. Whatever numeric column we have used for prediction, this gives the heat map for this. The intense value gives the high intensity of data here, and different intensities are shown here from +1 to -1. Similarly, this heat map is for transformed data set. Now, exploration of revenue by month. So, in May month, maximum revenue has been earned, and second is November, then March, December, October, July, September, August, June, and February. And this gives the percentage revenue. This is the exit rate based on visitor type by month. Exit rate based on visitor type by month, and this gives the correlation matrix of different data. Same there are we have included more data: administrative duration, informational duration, product related duration, bounce rates, exit rate, page values, revenues, etc. Then this is the summary of whole data set. So this is completion of first phase. Now come to second phase. Second phase is actually it is combination of two phase, ETL and feature engineering. I have done ETL and feature engineering together. Initially we start with reading the scalar library, panda library, and import the min-max scalar power transformation, power transformer. Initially reading the data, then transferring the data, whatever missing values are there, the exploration, and then we scale our data through scalar, min-max scalar, and power transfer apply. Then we save the data, transform data, and finally the state of scalar and transformer are saved so that it can be used to rescale if necessary, and import the pickle, and pickle has dump in the current library. So this is end of feature engineering and ETL, extract transform load phase. Now come to the final phase. This phase covers model definition, model training, model evaluation, and model deployment. Here we have compared three times the algorithm using different steps three times. So initially we start with optimization and selection for gradient boosted tree. So this is the import of library, then is reading the data, separate the label, split object for training and testing. Then we define the LGB optimizer. This is a function to optimize LGB classifier, and we start training. Initially we start with splitting the data, and then train the data. So it shows the mean value of 0.7665 and standard value of 0.0088, standard deviation. For a scale data set, again it predicts some values like 0.76529 and 0.02119. After that, we calculate the same thing for transform data set. Then we build the model. There are the parameters, label, parameter, train the model, classifier used as Keras, and here classifier is LGB, and print the best model, best scaled and best transformed. So these are the values coming from same thing. Then result is data set type encoded, scaled and transformed. So this is the training score and this is the testing score. um, Between training and testing score there is some difference. It is not exact. And then come to optimization and selection for neural network. So we start we start using TensorFlow, and we define the model. Then Keras optimizer we have used, and finally this is the value: data set type, train score, test score, train score and test score for neural network and boosted tree algorithm. Now we save the model as pickle, and this gives the future engineering. So this is actual we have done whatever given as per standard we have done, and additionally we have calculated um, modeling of SVM, logistic regression, um, neural network and RF. So data pre-processing is done. This is just for avoiding any ambiguity. And then train test split is done. Function for calculating the accuracy, this is the function we have defined to calculate the accuracy. Then model building is starting. So support vector machine is there, and for support vector machine it gives 88%. For logistic regression it gives 88.18, and for random forest it gives 89.48 or 49. For neural network approach, the neural network takes more time, and it gives 87.74. And after comparing, actually in a previous model it gives 88.96, 88.18 and 88.87. So we have just plotted to compare the model. So this is one another comparison of model. And finally we have started with different algorithm: logistic regression, again tree, XGBoost, neural network, light GM with grid search. So here ETL phase completed, and after that we started with logistic regression. So it gives the heat map for logistic regression, and the accuracy is 0.88 or 88.50%. Similarly for decision tree it gives accuracy of 0.90, very good. And then this is the linear regression ROC, and area under curve score, receiver operating characteristic and area underscore curve chart. And after that we use X boost algorithm, and finally we evaluate the X boost. And next we start with neural network, and neural network using TensorFlow and Keras libraries. And it gives the accuracy of 0.88, although it takes time, but 0.88% it has shown the accuracy. After that, light GBM classifier we have used, and light GBM classifier requires very big amount of time. And after that it gives 90.51% of accuracy. Then light GM classification with grid search give, it requires really most means it requires very huge amount of time, and it gives accuracy of 90.87. And Finally, we evaluated the model. So, logistic regression 88%, F1 score 0.49, 0.67. So, this is the comparison, accuracy comparison of different models. Here, best accuracy is shown by light GM grid search algorithm, and in this particular case, F1 score is best for light GM, and RSC AUC score is also best for light GM. So in conclusion, light GM is good model, although it takes more time. So this is conclusion of my project. Thank you.